this is the module on problem solving. So where does problem solving fit with Lean Sigma? It's actually part of the Jidoka family. So the objectives of this module are to have a structured method of investigating and resolving problems. Also to understand the tools used and confirm the status of the task at each stage. And to deep dive into problems to ensure they are resolved 100%. So what's the definition of problem solving? So to truly solve a problem, you must eliminate the root cause rather than manage the effects. So why is it important? Every problem solved eliminates waste and increases customer satisfaction. It gives ownership of issues to the relevant parties. It creates a standard approach, and therefore cross-functional teams are easily assembled. So what we're going to use here in this module is something called PDCA, or Plan, Do, Check, Act. So plan is planning thoroughly what you're going to do. Doing is doing exactly as planned. The C is to check in an accurate manner. And the A, act accordingly and promptly. So when a proven solution is found, the only method of sustaining that improvement is through standardisation. And we've spoken quite a lot about standardisation previously. It is and always will be the foundation stone of any improvement methodology. So the structured approach that we're going to use, we're going to record the problem, we're going to assign an owner, form the best team for that specific problem, use the best tools for that job. We're going to record the results and share the learning within the organisation. So recording the problem. One method we could use is a problem resolution sheet. It's not the only one, but it's one we're going to use here in this module. The 6 steps we're going to go through for problem solving here, following the PDCA cycle. First of all, we're going to get the first impressions of the problem. We're going to make the true problem clear. We're going to identify the location of the problem cause. We're going to interrogate the problem cause. We're going to identify the most likely probable cause. Then we'll analyse the probable cause. Then we'll uncover the root cause, plan a containment, implement the containment action, plan a countermeasure, implement the countermeasure, and then check that that has been sustained. So the problem resolution sheet, each stage of this problem solving process is recorded using a standard sheet known as a problem resolution sheet. So what we're going to do with this is form a team, clarify the problem and locate the cause, analyse the cause and identify the probable cause, interrogate the probable cause to find the root cause, put the containment action in place, brainstorm a countermeasure, plan and implement that countermeasure, then we'll review that countermeasure's effectiveness. Again, here's an example of a problem resolution sheet. So, first step, first impression of a problem. Most people, when faced with a reported problem for the first time, tend to do the following. They'll listen to hearsay about problems, they'll make assumptions about the likely causes. This distorts the real truth and problems appear larger than they really are. Remember this simple saying next time you're faced with a problem. To assume is to make an ass of you and me. So step 1, problem cause. There are 2 basic methods of clarification and both have their own place as to when they should be used. You've got the Pareto analysis, best used where sufficient data is already available or can be collected quickly. The second one, process flow maps, identifies a sequence of events that should occur to produce a quality product or process. Using basic elimination techniques, the problem cause can be easily identified. So, identifying the cause. Each entry should be written as if task completed correctly. So for example, the correct component fitted rather than wrong component fitted. So you're not stating what is wrong, you're stating what should have happened. So this is the problem caused as the first in a chain of events to be wrongly executed. Step 2, identify the probable cause. Once we've found the cause, this must then be interrogated to establish the probable cause. This is best done using a structured brainstorming tool known as the cause and effect diagram. This is what a blank cause and effect diagram looks like. And then we get into brainstorming. Golden rules: no idea should be mocked, nobody should be refused a turn, every suggestion offered should be recorded. Here's what that looks like, following on from the brainstorming session and populated the cause and effect diagram, also known as a fishbone diagram, also known as an Ishikawa diagram. This is after the technique's inventor, Kaoru Ishikawa, who's regarded as a leading contributor to Japanese quality management. Next stage, nominal group technique. Unless a probable cause is consent by the group, you may take the wrong path with subsequent problem-solving activities. This can happen quite easily if there's a dominant team member, so the emotion can be removed from the process using the nominal group technique. Make a simple graph and take the 5 most likely ideas. Grade each from 1 being the least likely to 5 being the most likely. Then total the scores for the 5 ideas. A consensus of opinion can now be drawn. Here's an example. So, if Sean had been a powerful member of the group, he could have persuaded the team to waste time addressing idea A, whereas getting everyone's score on it, that proves it was just his opinion that idea A was the one most likely to produce results. So step 3, root cause investigation. The root cause is the key element of the problem, which when resolved will prevent reoccurrence. The tool used to identify the root cause is 5 whys. In theory, this appears to be the simplest of techniques, but in practice it's significantly harder than anything else you'll encounter in the problem-solving process. The aim is to ask why of the direct cause, and then to ask why of the subsequent answers, until the question why has been asked an average of 5 times. So, in this example, so why has the machine stopped? Answer, the fuse has blown. So why did the fuse blow? Answer, a lack of oil on the drive shaft. So why is there insufficient oil on the drive shaft? Answer, the oil pump isn't working. Now the temptation could be, we've got the root cause, we'll change the oil pump. We'll continue to ask why though. So why is the oil pump not working? Because the filter is blocked with swarf. Now for those who don't know, swarf are metal shavings in a machining process. So why is the filter blocked with swarf? Answer, there is no cleaning procedure. So the root cause is a lack of a cleaning procedure. So if you can address that, you can then address the subsequent issues and prevent reoccurrence of the problem. Next step, containment action. So once the root cause has been identified, a short-term solution is required. This is known as a containment action and will alleviate the immediate concern. Traditionally, this type of solution becomes a long-term fix, eliminating the customer concern. The waste, however, of rework or over-processing remains within the organisation. So this is often known as a workaround. So it's a quick fix in order to just get things going again, and the danger is that you leave it at that and never get to the actual root cause. Step 5, countermeasure. So a countermeasure or elimination of the root cause is now required. This can be achieved using tools illustrated earlier. So solution and effects diagrams. So this is the reversal of the cause and effects diagram. Brainstorming, or the nominal group technique. Once you've decided upon the best agreed countermeasure, you'll need to plan its implementation. The planning stage is very important to you as the owner so that you're able to carry out the following. Regularly review progress of the project versus the plan, assign ownership to those involved, report back accurately regarding the status, support those areas where slippage is occurring, save information to use as a reference for similar issues in the future. Here's an example of a countermeasure plan. So the above 7 actions should always be included as part of the implementation plan. So first of all, containment action in place. Second, resource allocation for the project. Third, planning what the countermeasure will look like. Fourth, establish the countermeasure. 5, train those involved in using the countermeasure. 6, set the implementation date. 7, status review meetings. The review of the plan should look like this, whether you're behind schedule, ahead of schedule, or actually on schedule. Step 6, review the countermeasure. So develop a plan to check that the countermeasure has worked. The best method of doing this is to remove the containment action. So use the same method as previously illustrated to check and review the status of the countermeasure. Measure the following things. So key performance indicators. Is the process or product repeatably to the required standard? Are there any new effects? Have the processes you've introduced caused any new issues? Step 6. Standardise the countermeasure. Once a team is happy that the countermeasure is successful, they then need to standardise it. This can be done using several methods, from placing on daily checklists or writing a formal procedure to implementing a mechanical method company-wide on all like processes. These could include daily checklists, formal procedures, or your mechanical method. That's the end of problem solving. Thank you.